Hi class, this is Mrs. Albritton. So I'm going to do problem number 1 a second time, but this time I'm going to switch up the steps just a little bit. I am going to multiply the coefficients first, but I'm going to simplify the radicands so that I can make the numbers a little bit smaller, because remember, you will not be able to use a calculator. So I'm going to start with the problem 7 radical 12 times 5 radical 9. And let me simplify the square root of 12 using a factor tree. So I've got 4 times 3, and then 4 can be broken into 2 times 2. So my prime numbers are 2 times 2 times 3. I can do the same for my 9. Now, I don't know if you noticed, but the square root of 9 is a perfect square. Even if I break it apart, we get 3 times 3. Those are both primes. So here, when I circle my pairs, that tells me what I need to pull out to the outside of my radical. So this problem actually is going to end up looking like this: 7 from the coefficient that was originally there times 2, because you pull one of the numbers out of the pair. And we leave what was not paired up, which was the 3. So radical 3 times the 5 that was originally in the problem. And we've got a pair of 3s, so that will be times 3. So look at what we have. 7 times 2 is 14 radical 3 times 5 times 3 is 15. Now, the steps, remember the steps. Say step 1, you multiply the coefficients. Those are the numbers outside the radicals. So I've got 14 times 15 because there's no longer a radical here. That gives me 210. And then I just bring the only radical that I have left down. So we still end up getting the letter D. All right, let's get number 2. So I'm going to move this up a little bit. Look at the radical 12 square root of 175. What is the rewritten form of the radical? And the bullet, what is the expression rewritten form of the radical asking you to do? It's asking you to simplify. So let's go ahead and do that. You've got 12 times the square root of 175. Again, you will not have a calculator, so you're going to have to do the factor tree on your own. When I look at 175, I automatically know that it is divisible by 5 because it ends with a 5. So I know I can at least start with 5 times some number, and that other factor would be 35. And then I can break 35 up into 5 times 7. Prime, prime, prime. So I know I stop here. So the new problem looks like 12, which was already there. I've got a pair of 5s here. So I'm going to rewrite 175 as the product of the prime factors that we just derived from our factor tree. I can pair up these 5s. So now I've got 12 times one of the 5 comes out of the radical, and the 7 has to stay because it wasn't paired up with anything else. So when I multiply 12 times 5, I end up with 60 radical 7. And that is letter A. All right, let's get number 3. So I'm going to slide this up a little bit. Number 3, look at the expression 4 radical 10 times radical 8. Which of these is equivalent to this expression? And the bullet point asks you, what does it mean when it asks is equivalent to? Again, that means what is equal to. So they just want you to work the problem out. Well, this is a multiplication. I've got 4 square root of 10 times square root of 8. Again, the steps for multiplying are step 1, multiply the radicands. I see the the coefficients. Keep saying that. The coefficients. So I see 4, but I don't see a coefficient here. And remember, if you don't see a coefficient, it's understood to be a 1. So in this case, I have 4 times 1, which gives me 4. And I have 10 times 8, which gives me 80. Now I've got to simplify. because I've done step 1, multiply the coefficients. I've done step 2, multiply the radicands, and that gave me 80. Step 3, simplify. So it simplified 80. Need to break that apart using a factor tree. I'll use 8 times 10. There are other factors, but I'll just use 8 times 10. Here I get 4 times 2, and I get 2 times 5. Prime, this is prime. However, 2 times 2 will give me 4. So here's 2 more primes. So this problem actually becomes the 4 that was originally here. And I can rewrite the square root of 80 as the 2, another 2, a third 2, the fourth one, and the 5. These are all the prime factors that I pulled off the factor tree. And now we group any pairs. So 4 is there from the original 4, the original coefficient. And I pull out one of the 2's for this pair and one of the 2's for the second pair. Since the 5 doesn't have a pair, it wasn't matched up with anything, it has to stay under the radical sign. And then when I multiply 4 times 2, I get 8. 8 times 2 is 16, radical 5. So my answer is C. All right, and I'll finish up on the next video.